Hi, 6th grade. Today we are going to be talking about melting. So this is on page 309 in your textbook. And we really want to focus in on when we're talking about the changes of state. We want to look for thermal energy. Are we increasing or decreasing thermal energy? What I noticed on your pretest, a lot of you said that the causes of change of state is because it's an increase in temperature or we're increasing heat. And you're on the right track, but now we know that temperature is just a measurement. We can't really increase temperature. It's kind of an effect. We can cause the temperature to increase by adding thermal energy to something. So we really want to start using the term thermal energy. So looking for, is the thermal energy increasing or decreasing? What state, obviously, what state do we start off with and what state do we end up with? And then what's going on with the particles, because we've been dealing a lot with particle arrangement and particle movement. So let's go ahead and let's get busy reading. Melting. The change in state from a solid to a liquid is called melting. In pure crystalline solids, melting occurs at a specific temperature, called the melting point. Because the melting point is a characteristic property of a substance, chemists often compare melting points when trying to identify an unknown material. The melting point of pure water, for example, is 0 degrees Celsius at sea level. So, and if you took a look at the thermometer from the last reading, 0 degrees Celsius is the same as 32 degrees Fahrenheit. So let's go ahead and pull up our notes. We're starting off with melting. And right away it tells us what state we're starting off with and what state we're ending up with. So we are going from a solid to a liquid. Now it does have melting point highlighted in your reading, but that's not something that I really am concerned with you guys knowing. Let's just kind of talk about it for a little bit. The melting point, all that is it's the temperature at which something will melt. So that is with only crystalline solids. Amorphous solids, they slowly melt over a range of temperatures, whereas the crystalline, they hit a specific temperature and they will start to melt. Why I kind of wanted to bring this up, it kind of goes along with density. We could use density to help us identify substances. So the melting point is another characteristic that scientists look at to help identify substances as well. So I just thought that that was kind of neat that we could kind of add that to our list of when we're identifying substances, we can use density and the melting point. So what happens to the particles of a solid as it melts? Think of an ice cube taken from the freezer. The energy needed to melt the ice comes mostly from the air in the room. At first, the added thermal energy makes the water molecules vibrate faster, raising their temperature. At a solid's melting point, its particles vibrate so fast that they break free from their fixed positions. At 0 degrees Celsius, the temperature of the ice stops increasing. Any added energy continues to change the arrangement of the water molecules from ice crystals into liquid water. The ice melts. So let's just kind of take a look here. When we're going, so we said solid to a liquid, and I said I want you to be focusing on the thermal energy. Does it increase or decrease? Do we need to increase or decrease the amount of thermal energy in order to get something to melt? So I want you to go back and reread and find that. Okay, so you should have seen that we are actually increasing the thermal energy. And they give us examples of how we can, increase the thermal energy. Where does that energy come from to melt something? So a lot of times when you're dealing with ice, it might be the air. Or when you put ice into the pop is warmer, and so we're getting thermal energy from the pop. So it could come from the liquid that's surrounding it. We might get thermal energy from the sun. What's melting the snow? Well, the air gets warmed up by the sun. So we can increase that thermal energy by, a lot of different things. Now, the other thing that you needed to look at was what is happening to the particles. So when we increase energy, the particles are going to start vibrating faster. So the solid's particles start to vibrate faster until they vibrate so fast that they break free from their fixed positions. And I actually have just a short little clip that I'm going to show you guys so that you can actually see what would happen in the particles of ice. Okay, so we know as the ice is heated, the motion of the molecules increase. So eventually the motion overcomes the attraction between the molecules and the ice melts and becomes a liquid. So you can see that right now they're just vibrating slowly and they're in those patterns. And then we start to increase the thermal energy and they start to vibrate faster and faster till finally they're vibrating so fast that they're actually able to move out of those fixed positions, and now they're moving like a liquid. And you can kind of see that some of them are a little bit attracted to one another, which is giving us that surface tension. Okay, so those are our notes on melting. You're now ready to do your melting investigation.